Good morning, my dear friends, my dear students. Today we are going to discuss very important and easiest problem from random process. Okay, let us take an example. Consider two random process. X of t is equal to 3 into cos wt plus theta, and y of t is equal to 2 cos wt plus theta minus pi by 2, where theta is a random variable uniformly distributed in 0 comma 2 pi. Prove that square root of rxx0 into ryy0 greater than or equal to modulus rxy of tau, isn't it? So before we are going to proceed this problem, kindly subscribe this channel, share this video to your friends, and give like symbol. Thank you. Then proceed. Okay, this is the solution. Given these two things, x of t, y of t, we are given, and theta is also distributed uniformly within the period 0 comma 2 pi. So let us take f of theta equal to 1 by 2 pi. The theta lies in between 0 to 2 pi. Okay, next write the autocorrelation for x. It can be written as t comma t plus tau. Okay, it is a value. Okay, so autocorrelation can be written as e of, that is expectation of x of t into x of t plus tau. So this is the formula for autocorrelation, and then just replace x of t by 3 cos wt plus theta, which is given right as it is, no change. But the second thing, t plus tau, so wherever we have t, add t plus tau, isn't it? So replace by t plus tau, so the next term become 3 into cos wt plus w omega plus theta. Okay, this is a change. And the next thing, autocorrelation rxx t comma t plus tau will be, so both term we have 9, 3 into 3 9, and multiply and divide by 2, so that why I am doing this in this place. See the next level, there is a formula cos a cos b can be written as 1 by 2 cos a plus b plus cos a minus b, isn't it? So there is a 2 is missing in the previous term, so that I have to add, multiply and divide by both terms, isn't it? So e of cos wt plus theta into cos wt plus w tau plus theta, isn't it? So 9 by 2 already is there. So expectation of that one, using the formula cos a plus b omega wt 2 wt, and then 2 theta, there are two terms theta, so that theta plus theta 2 theta, and then w omega, this is cos a plus b plus cos a minus b. So wt minus wt cancel, theta and theta cancel, so we have only w tau. Okay, okay, now, so after substituting this, 9 by 2 is a constant for the both terms. Then the first term becomes, integrate 0 to 2 pi cos 2 wt plus 2 theta w tau into d theta into f of theta, that is 1 by 2 pi. F of theta already we have taken 1 by 2 pi plus 9 by 2 cos tau. It has no integral since it has no theta, but the first term we have theta, so that we can able to integrate, so that first term only has integration. The second term there is no integration, isn't it? So I have written the formula in uh, the next line, isn't it? Okay, using these concept we can proceed. So 9, so there is a after integrating cos, it will become sine. Okay, sine 2 wt plus 2 theta plus w tau by 2 from 0 to 2 pi. 9 by 2 cos w tau capacities, and then take this 2 outside, and then 1 by 2 sine of this is, I mean, upper limit, so 2 theta becomes 4 pi minus lower limit, so the second term will be 0, and then go to the next term, 9 by 2 cos w tau capacities. So take 1 by 2 outside, so it is um, it has I think 9 by 8 pi. So sine 2 wt plus w tau minus sine 2 wt plus w tau. So unlike terms, it can be eliminated, so we have only 9 by 2 cos tau. So autocorrelation of x, isn't it? T comma t plus tau will be 9 by 2 cos tau. So next line, similarly we can prove r y y t comma t plus tau. so which is equal to 2 cos w tau. It is a autocorrelation for y. So okay, now substitute tau rxx of 0 is equal to 9 by 2. So it becomes cos 0, it becomes 1, so that 9 by 2. Go to the second one, cos 0 will be 1, so we have only 2. Okay, so what does it mean actually? So in autocorrelation the initial value is 0, so the term becomes 9 by 2 under 2. Now the jointly autocorrelation x into y jointly, isn't it? So t comma t plus tau is equal to e of x comma x of t y of t plus tau. So x of t right as it is, and y becomes t plus tau. So substitute the values. So 3 into cos wt plus theta, it is x of t. What about y of t plus tau? 2 into cos. So the wt becomes wt plus w tau plus theta and minus pi by 2, which is given in the problem. So 3 2s are 6 by 2 e of sine 2 e of sine 2 wt plus w tau plus 2 theta plus e of sine w tau. So how this has happened? So cos a cos b is equal to sine a plus b plus sine a minus b. So that I have using that formula, so the term becomes sine, isn't it? Okay, next line. So the jointly autocorrelated is equal to 3 into e of sine 2 wt plus w tau plus 2 theta plus sine w tau. Okay, so already we have written in the previous line. Okay, now in the two terms, the first term can be integrated, the second term there is no theta, so that right as it is a constant 0 to 2 pi sine of the term into f of theta, that is 1 by 2 pi, already we have used in the previous term. So sine w tau right as it is. After integrating sine, it can become minus you can take outside, so 3 by 2 pi. 2 pi is also constant, I can take outside, so sine become cos, so 2 wt plus w tau plus 2 theta by 2. So the range from 0 to 2 pi plus 3 into sine w tau, and then I can take 2 outside, so minus 3 by 4 pi cos 2 wt plus w tau plus 4 pi, that is upper limit minus lower limit, then plus the last term 3 sine w tau. Then there is a unlike terms, first term plus second term minus, and then plus 3 sine wt. So the two terms cancelled, so the jointly correlated autocorrelated is equal to 3 sine w tau. X of t and y of t are jointly wide sense stationary, isn't it? So from that we can conclude that both x and y are jointly wide sense stationary. Okay, now substitute 0 for the both terms. Already we have found, isn't it? 9 by 2 into 2 equal to 9. Taking square root on both sides, so rxx of 0 into ryy of 0 equal to root 9 equal to 3. Since rxx of tau is equal to 3 sine tau. Okay, already we have found rxx 3 tau. Taking modulus, so modulus 3 which is less than or equal to 3. Okay, now rxy tau less than or equal to, so 3 is replaced by square root of rxx 0 into ry by 0. Okay, so it is proved. Okay, thank you my dear friends. If you have any doubt, put it in the chat box.